Our task then, taking kind of what we did from the WOMP, is if we're going to have base function x squared, you're going to give the vertex and direction by writing a function. Now, if you're looking to get a vertex, what form is probably popping? Probably vertex form, all right? And then you got to remember our card sort yesterday. You got to recall what makes it open up versus what makes it open down. And you're going to write functions for A, B, C. We will stop there. You don't have to worry about 2 because I'll just confirm, and then I'll get you set up for number 3 when we get there. So just number 1 ABC for now. Okay, so let's talk about what's going on here. I've got my base x squared. How do I shift it 11 up for 0, 11? Plus 11. All right. Plus 11 on my constant is going to shift the whole thing up 11. Now, we're going to need to use vertex form since I need a vertex at 7, 11, which is an x minus 7. That'll shift me 7 right, squared. And then it still needs to go up 11. This one opens up, so I'm all good. Again, in vertex form, this says my vertex is at 7, 11, and it opens up. The only difference for C is it needs to open down, so it needs to be negative. I still need to shift 7 right. And then my y-intercept, or my y-axis, I said that wrong twice now. My vertex has a y value of negative 3. So those are my 3 equations that match the vertex needed and the direction it's pointing. The vertex is dictated by what this would need to be to make a new 0. And the y, and it looks like the y-intercept, but we shifted left or right first, right? So it's going to just shift it up or down. We're not on the y-axis anymore once we've shifted to left or right. Are you guys do you guys see what I mean by shifting? Like, I think the visual is great. This makes us go 7 right. So this is no longer the y-intercept because once I go 7 right of the y and then up 11, I'm not on the y-intercept. 7, 11 is the vertex, which is what was given. Yep. Cool. So here's what we're going to do. Kieran noticed that, oops, wrong screen. Kieran noticed that if I had my base x squared plus 1, we can imagine that is that normal parabola we mess with a lot, just shifted up 1. But to move it to the right 3, he did x minus 3 squared instead of x squared. Everybody go with that? That moves it right 3. Has the same plus 1 there. And that gave us 0.31 for the vertex. Because when x is 3, y is 1. 3, 1. Then he graphed x squared plus 2x plus 1 and saw here the vertex is negative 1. We were doing that the other day. Negative b over 2a, so negative 2 over 2 is negative 1. So Kieran's like, hey, I want to shift this 5 right. So up here, to shift it 3 right, we did x minus 3. Here, to shift 5 right, x minus 5. That makes sense, right? And then the vertex would be 4, 0, because 5 right of negative 1, 0 is 4, 0. So is Kieran correct in saying that we can shift 5 right by putting x minus 5 in instead of x squared? Just like x minus 3 instead of x squared shifted us 3 right. You need to say yes, no, yes or no, and then justify your answer. This one's going to take a little longer, just a tad longer. So yes or no, and then justify your answer with some math. So let's start off with a vote. Who says yes, it works?
Wow.
Man, every class today, someone has said yes, it works. Okay. Who says no, it doesn't? Everybody else. Well, let me start by proving to you why it doesn't work, okay? Oops, wrong thing. I'm going to get a little space here. So it doesn't work. Like, the logic makes sense. I follow the logic now, and I'm a believer. But if this is the function, and x minus 5 is going to work, right? That means if I say x is 4, or if this is going to work, if x is 4, shouldn't this pump out 0? This is going to pump out 10.
Yeah, that's incorrect.
And is 4, 10 the vertex that they're looking for? No, it'd be 4, 0. So now let's get to the y. So when we had the x minus 3 squared, what was that? I erased down here. X minus 3 plus, what was that? To shift it right? You guys from your notes? Plus 1. instead of x squared plus 1, okay, the constant stayed the same, and the quadratic term said shift 3 to the right. Now, notice down here, we don't just have a quadratic term, we also have a linear term. And then you're like, well, yeah, and then there's the constant. Well, why doesn't the constant change for a shift right? If I go right or left, does it change my y value at all? No. So the constant doesn't care. But the linear portion does matter if I'm shifting right. I got to shift the quadratic and the linear. So, no, it's no for this reason. Would you guys like to know well, you're going to. We're going to show you how to shift the whole thing to the right if it's in standard form with a linear term. And it looks like this. We do need the x minus 5 squared. But then we also need to shift our linear portion right 5 as well. The constant doesn't care because if I shift right, it's still up 1. Right? Are you guys seeing that visual? If I'm shifting right, it's still up 1. So the big picture here is, if it's vertex form, this works every time because what is unlisted? Which term is unlisted?
The linear.
The linear term because it's 0. Here, linear term listed. You need to mess with the linear term if you're going to shift the whole thing to the right. Okay? Everybody follow the difference? All right, now let's talk about this. Let's talk about this peanut. Okay? Oops. So, May is doing a computer animation, and part of this animation is getting this peanut to jump over the wall. All right? And she's using this equation right here. Oop, miscircled. Right here. All right? What you need to do is start right now by writing the function for the peanut's current path. Write the function for the peanut's current path. So who can hook me up with the vertex? What is the vertex for this peanut's jump? How high is this peanut even jumping for real?
18.5.
It's not jumping 18 high, but the vertex is 0.185. So it's jumping 5 whatever it is. This peanut's got hops, 5 feet. Okay? So now I'm going to write it in the vertex form. Y equals negative 0.1 x minus 18. So that's shifting us right 18. And then how do I shift up 5? Plus 5. Oh, I forgot the square there to make quadratic. So that is the current path.
Okay.
What you are charged with... So what's going to happen to this peanut?
It's gonna fall.
We're making peanut butter, okay?
It's gonna crack.
It's going to hit that thing and turn into peanut butter. We want it to clear that, but we also want it to stay in frame. So I want you to come up with a new function that would allow our peanut to clear the wall, not turn into peanut butter, until it lands safely on the ground on its fake peanut legs. Okay? And has to stay in frame. Give me a new function. Eyes on the board, mouths closed, please. So I think there's a couple ways we can go after this. There's more than one right answer. I'll tell you the way I personally saw things happening, and then we'll talk about others. I personally saw, well, let me write where we started. Maybe 0.1 x, I know I already had it. 18 squared plus 5. So I was looking at this, and I was like, he goes high enough. This peanut's high enough. So I was like, if I could get it to hit this spot right here, will it clear it?
Yes.
It's going to clear it. If I made that my new vertex, 22.5, it's going to clear it. So the only thing I would need to do to make that my new vertex is how would I need to shift it? 3 to the right. Or 4 to the right. Sorry, 4 to the right, correct? So I was like, this would work. Same thing. But 4 more to the right would give me x minus 22 squared plus 5. 5's high. So that's one thing you could have done. That's what I saw. I said, I just shift the whole thing to the right, it'll clear it. All right, no more peanut butter. But something else you could do is say, well, if he got that high, it also looks like he'll probably clear it, right? Are you guys seeing that?
Yeah, you don't
Well,
have
it depends on the incline.
It's the same incline because we got negative 0.1 still.
Then you don't have to change the minus.
So it's something like,
Well, what would the mass of the peanut can't get that high? Because
Well, yeah, this fictional peanut jumping. We don't know its mass. Also, who's not saying this ain't on the moon, you know? But anyway, we could just change our vertex like that. Instead of shifting it to the right, which way are we shifting it? Up. So, I could still have the x minus 18 squared. But instead of at 5, it's going to go up to 7. That's another thing we can consider. I feel like this, though, here, or here, more guaranteed. You know what I mean? Because the highest point is over the highest point it needs to go. But we could consider some points over here. Now, I'm going to go, not for the video, but I'm going to go check some of these out on a little animation, okay? On the computer. Let's see what happens to this peanut. Last thing for the whole unit, you are going to write functions for each part of the smiley face, the mouth, and each eye. With that, though, right, these parabolas theoretically go on forever. So you need to give a domain with it in order to have it be that segmented portion of your function. Two things I want to point out. Do you guys notice the x and y scales aren't the same? Okay, so that's why it doesn't look perfectly x squared. Also, we already know how to make things point up. We know how to make things point down. And we know how to shift the vertex. If we're shifting a vertex, what form are we probably messing with? Vertex. And these are all base x squared. So we don't need to make it like a narrower or wider. They're all base x squared. Because what's the only thing we need? A vertex. I'm going to let someone vote. I don't care which one we do first. Raise your hand if you like to pick which one we do first. All right, Brandon?
The smile.
Okay, we're doing the mouth first. And my vertex is 0, 10. So in vertex form or whatever form, I'm taking my x squared and I'm shifting it. Up 10 is all I'm doing. X squared plus 10. I'm taking my x squared, I'm shifting it up 10.
Yep.
All right?
Pardon the interruption, will the following please come to the learning comments. Fiona Bachheim,
I can pause
Emmett
this.
Sheff.
All right, and so then with this, I need this domain, which is going to cut me off on the ends. Are you guys seeing the domain from -4 to 4? Okay. So again, x squared base, shift up 10. X squared plus 10. All right, who wants to vote on which eye we're going to mess with first? All right, Sean, which eye? Left eye. Left eye is a person that was in a band called TLC. So right here, I have vertex -250. Who can tell me the two shifts I would need to make to change my vertex from 0, 0 to -250? Sean?
You need to shift it up 50 and to the left.
So 2 left is going to be x plus 2 squared. And then up 50. But this is still not right yet.
You need a negative.
I need a negative to make it point down. Remember matching those yesterday? We looked for that to be negative or positive.
You just do x minus 2.
And then we need a domain from -3 to -1 for it to make the left eye. Any vote on which eye we do next?
I think we'll do
Let's do the right eye.
left eye.
Let's do the right eye.
Do
I was thinking the third eye.
the upper eye.
All right.
Third eye.
And that eye's vertex is at 250.
You should do the 7th eye.
So again, x squared has a vertex right here, right? I'm gonna shift it 2 to the right, up 50, and then it has to point downward, so negative. It is going to go from 1 to 3. That gives me my right eye. It's all about where I'm shifting that vertex, right? That's how vertex form works. We're shifting it left or right, then up or down to where the vertex is. And then just remember, that negative's got me pointing down, that positive's got me pointing up. All right? All right.